Hey everybody, welcome to the channel. In this video, I wanted to go over the technical details on the desk here, the single drawer. I want to talk about the beginning of this concept and the future outlooks. I also want to explain why it has taken so long and is it even possible to buy or not. So first of all, if you haven't watched my latest video on the build here, go ahead and watch that first. It's in the description. It kind of makes more sense what I'm about to talk about. And the demand has been incredible for a product like this. I've had literally thousands of people messaging me, can I buy this? Where can I buy this? What's the cost? And all of that. And I haven't really had a product yet. Now this is a real product. What I'm going to do is I'm going to start out with a straw poll where I ask a very simple question. Would you pay the price for this drawer, which is $1,500 US? And for the desk here, with a drawer, of course, no PC installed at all, the price is $3,000, around there. It's a approximation. Would you be willing to pay that price for this handmade, high-quality carpentry product? And when I get an overview of where things are, I'm going to progress from there, do a Kickstarter, and so on and so forth. Right now, due to the Rona situation, shipping is almost impossible. So I'm gonna take it one step at a time. All right, the goal with this channel, first of all, is to make awesome and inspiring and creative and just different videos from what you're used to seeing. I want to really move you guys when you watch my videos. If you don't feel anything, if it doesn't really interest you, I mean, that's okay. But let me know if there's something I'm missing. Please, it helps out a ton. So thanks for everyone who has been helping. It really means a lot. All right, let's talk about the improvements here. So this is the version 2.0. This desktop here has been improved, especially on the structure of the table. So the desk before was made out of 2 sheets of chipboard with oak veneer on the bottom and top. And the distance between the glass and the front of the drawer here was very short, only about a few inches, which just means that the structure is very poor in the table. It's quite easy for it to break, actually. Now what I did here is with the new drawer, it has this hidden compartment where it allows me to hide that section and get more wood. It's also made out of 30 millimeters solid oak wood. And the solid wood is a lot stronger and helps mitigate some of that sagging you had in the middle here before. I've also installed a diagonal support bracket from the front left leg all the way to the back, which again helps alleviate the sagging effect you get here. Now, the reason you have this sagging effect is because normally on a table you have a structure underneath. You have this support, these 4 support brackets where the desktop, the tabletop is then laid on top of that. And you know, it's the support brackets and the legs that give it the structure, not the table itself necessarily. So when you don't have that here, you need to be creative, otherwise you'll get this sagging effect. But this actually solves the problem quite well, and I'm very, very pleased with it. Also, safety is a huge concern here. If you spill something, drop something, pull out the drawer and it drops to the ground, that's devastating. So it's very important that I addressed this issue seriously, and I did. What is installed here is a 5 millimeters polycarbonate scratch-free and, according to the manufacturers, also bulletproof sheet, which is inserted from the bottom up and then glued into place. It also has a silicone on top and seals off so fluids won't get into it. So it actually kind of feels more like a safe that protects the computer rather than a sheet of hardened glass that is, you know, easily going to break or shatter. Also, if you have tension in your wood over time, a piece of glass can actually slowly but surely start to wedge itself and then crack because the wood is moving and living, so to speak. Then we have a knob plunger on the side here. How it works is that you pull out the knob plunger. You can then start taking out the drawer, pulling it out. Then you can release the knob plunger again. It inserts itself just onto the wood. And then you slowly pull out the drawer and it will insert itself into another hole that then locks it into place. So right now it's locked. I can pull out the knob, slide out the drawer just a little bit, release it, and then slide it out into another another configuration. That's like the show-off configuration for the drawer. And then it locks into place and it's safe again. You can then also pull it out all the way, rotate it and lock it into place, the knob plunger, and then you can pull out the drawer and do whatever you want. That's also what you do when you install the drawer, so that's pretty clever. Then finally we have the support bracket on the back here. I've cut out a few holes on the top and bottom and give it a chamfer just to make the airflow a lot better, or a tiny bit more efficient. It's all about efficiencies in the end. If you sum all the things that I do, it actually affects the computer in the end. So what it does is it just prevents the air from being trapped in any place, and then lowering the pressure inside the radiator. What you don't want is a low pressure in the radiator, because it's the pressure of air and the flow of air that is cooling the rad and cooling your water and then cooling your entire system. So yeah. So that is an overall view of the desk here. Let's move on to the drawer. All right, so let's go over what I've changed on the drawer here. So this is the single drawer that you can install under any table you want, to your liking, your style, whatever it might be. That's pretty cool. It has these rails on the side with a what's called touch release, which means that when this is installed, you just push the front and it clicks open and pushes itself out. And you can just grab the bottom or the top and pull it out further. And then when you want it back in again, you just simply push the front and it clicks in place, just like that. So the single drawer here is the layout in this is exactly the same as in the desk. There's no difference at all. But there's a difference from the previous prototype. So what I've done here, first of all, is the fans on the side are removed. So also what I wanted just at least to try is to optimize this drawer. So it's cool, yeah, it's different, yeah, it's, all these things, yes. But could we maybe modify it so we also save some money? Now you think, well, this product is not about saving money, isn't it? It's like the high-end product, right? And yeah, it is, but still, you don't, like, the best part is no part. And the guy who invented that term is a genius, because why have these fans? Maybe they make it just slightly better, but if I don't have them, there is nothing there. Like, it doesn't cost anything, doesn't weigh anything. There's no problems. It's just, I thought, what about just removing them? And then this guy who helped me quite a lot, Matthias here in Denmark, he's an expert on water cooling. He suggested that we had passive air intake, which means that there's only 3 fans. This also means that I will recommend that you put 3 very good fans. It's 120 as you usually use. So I think it's a good idea to choose some fans that are high performance and, if you can, also low noise, like the black noise fans. But you can go with whatever you want, basically. And how it works is that when this whole section here is going to be sealed off because of the table, or at least there's a very little room for the air to be pulled in. It's almost completely sealed off. So when these fans are spinning, they're going to be sucking in air, what's called passive air intake, and that's coming from the bottom. The bottom here, there's a grid where it's, or dust filter, where it's going to be, and all these holes, is going to be sucking up the air and forcing it through these huge holes on the back side of the motherboard, cooling off the motherboard, then coming into the chamber itself, cooling off the rest of the motherboard, and then passing through the fans and through the radiator itself. So that's just a different way of cooling your PC, and what it means to cool off your motherboard from the backside. It's actually really, really good for your component and components that your motherboard is cooled off from the back. It extends the longevity of your product and your hardware. So that's pretty cool. Let's just start out with, down here, the power supply. It's an SFX power supply, not the standard ATX, very important, but the power supplies these days, SFX, are getting so powerful, so it's no problem at all, and you can't install 2 GPUs anyway. I mean, you might be able to actually, but it's made for only 1 GPU. So you have your power supply over here. It's a little bit difficult to install that because of the bracket here, but it is doable, and you only need two of the screws. You can install 4, but 2 is fine. This is also something I might update later in the process, but it does work for now. Then you have your storage over here. There are 2 brackets. This big bracket here is for the hard disk drive. There's room for 1. Then I have smaller ones attached here. You can like peel them off here, and they're for the SSD. The idea here is that you only need the 2 small ones for 2 SSDs, and that's it. And then you have your NVMEs. The big bracket is so you have the option if necessary, but then you have to install your hard disk first if you want all 3, then the hard drive first. Then you install your SSDs into the small brackets, and then that sandwich of SSDs is glued onto with double adhesive tape to the hard drive. It's not optimal solution, but that's also something I definitely will try to improve on when I get some partners on board. Moving on, I have made the start button here, the power button, bigger. Before it was just a little bit smaller in diameter, so it looks better now. Also the front cover is different. It's CNC machined this time. The one I made before was just a last minute thing, so this looks really great in my opinion. I think it looks perfect now. 2 USB 3 connections and a USB-C. Now over here we have the SwiftTech pump-rest combo. The way this works is that, let's imagine water is being pulled from the radiator. It goes this way, down to some hidden tubing underneath, comes up here, through this tubing, through the wall, and into the pump rest. Then it goes through a hidden passage, or like a drilled through passage here, like at an angle. And then there is a tubing going under in this hidden compartment, going over here, with a pass-through fitting and a 90-degree fitting, which allows you to place that wherever you want. If you want it on top, on the bottom, on the side, you just drill the hole and you install it, and you continue your loop from there. This gives you the creative freedom. Of course, if you want me to put it somewhere, I'll just put it anywhere. It takes like 2 minutes to do, but it's just the creative freedom you can have there. Now, the idea with these tubings over here is that this section over here is the creative section. So the creative section I've chosen for a standard drawer. This is the standard that's going to be in every drawer, is a reservoir, so to speak. Now, this pump-rest combo here, you can't show that in any way, and if you put a cylindrical reservoir, it's going to collect a lot of air bubbles. So that's also why I went with the X-Flow radiator, because it doesn't collect and has the potential of collecting air bubbles the same way as a normal U-bend radiator or normal radiator would work. So I've really tried to work with these guys from Magnetron and his friends to come up with solutions that work in the end, and there will be no problems addressing later on. So Now again, this can be made different. This can go strictly directly into the ground, or into the bottom here, and this could come up over here or come up in the hidden compartment. You can do different things, maybe have your initials here or whatever. Actually, one thing I don't have in the drawer yet that I completely forgot, which is insane, is my name, my logo. Like MA Modified is nowhere, so that's a bummer, but that's going to be in the final version, definitely. And if you have a suggestion where you want that, actually, please let me know, because I have absolutely no idea. Maybe over here, I don't know. Yep, moving on. The radiator is a 60mm X-Flow radiator. This is standard. If you want a 40mm radiator, you can of course get that. You can get anything you want. This is custom made work, so we can do whatever, but this cools off your system no problem at all. Now, the way I've designed this is these silver diagonals, hex screws here are, bolts are for screwing the fans into the drawer itself. The other diagonal side here, the black ones are extenders from the radiator, which means that this just allows you to screw your fans into the drawer and the radiator. So when you only want to remove the drawer, the rad, to clean it, for example, for easy maintenance, you can just unscrew these two screws here, here, and here, and then remove that, and the fans will still be attached to the drawer. So that's just a cool feature. The standoffs are 20mm instead of 7. That's just to get more room, so you can wire your cables underneath the motherboard and into it. Looks cleaner, a lot less routing. Your GPU bracket on the side here. Connect your GPU as you normally do. Then it lays on top of this arm over here, which is the GPU support bracket. You can adjust this in height and width, all of that, to make it fit. And this just helps from, counters the sagging from the GPU. And then, of course, 2 holes over here for cables to the motherboard and cables to the graphics card. Yep. So, and yeah, a hole down here for the intake of the power supply, and the power supply is going to spit out air this way, which is fine. Again, components in this price range here is going to take care of these problems, no biggie at all. Moving on, we have this also comes pre-installed, which is a temperature sensor on the side of the radiator. I know this works with Asus motherboards. I don't know with other manufacturers though, but it measures the temperature of the water and then adjusts the fan speed accordingly. So you don't have peak temperatures always adjusting the levels or the RPM of the fans according to some peak temperatures on your components, but the actual temperature of your system, which is the temperature of the water. Included always is a 15cm riser cable, which fits perfectly from the motherboard to the GPU every single time. So yeah. Now, when it comes to installing your components, this drawer has great accessibility, which means that it's really easy to install everything, and it's open, it's very easy to move around and do stuff, and it's not tight spots and all of that. What you do is you flip your tabletop on its head. Then with this single drawer, you put it on top, you screw it in and line up the front here with the front of the desk. Then you flip it back again on its legs, and you simply just push the drawer out without anything installed, and then install your PC. What you do is you slide out the bottom here, slide it out the back, install your hardware, and then do the cable management underneath. And at the very, very end, when everything is said and done and tested out and it works, you slide the bottom right back in with the dust filter and all of that. And then it's good to go. Really easy to do, it's fun to play with. Also a feature I forgot actually here underneath at the back where the cables are supposed to come out of the drawer. I have installed it's going to be a silicone, like a membrane where cables can come out easily, but it blocks the air from being sucked back into the system. So when the fans are pushing air out and it comes out the back, it has a less of a chance to being sucked back into the system through the opening on the back. It's just, again, a minor feature. It really doesn't do a whole lot, but just a safety precaution so you don't have hot air being circulated in the same system. And again, when it comes to circulating hot air and these things, when fans are pushing through a radiator, it actually, it throws the hot air quite far. I don't know if you've seen performance tests with these things before, but you can have a sheet of paper pretty far away from the radiator and it still moves the paper, which means the pressure at a long distance is quite high. That's, again, it's just I'm just trying to explain that maybe some of you might be thinking, well, won't the air just go through the radiator and out the back and just go right back into the system again? And that's what I'm trying to say is something that won't happen. So. All right, so when you buy this product here, the price will be, like I said before, $1,500 US. And what does that include? The rails here, see on the sides, pre-installed and included. Everything you see here is included. All the brackets, the front I/O, pump res combo, the reservoir tubing, all the fittings, all the tubing underneath, this soft tubing here, this 90-degree fitting and pass-through fitting, the whole radiator as well, with the temperature sensor and the riser cable, all included. Now, I'm including this because it's just a way easier to do it this way, because I've modified a few things with the extenders here on the radiator, also on the pump reservoir combo from SwiftTech. This fits perfectly. Notice it's just barely touching the surface here, which is ideal. And I've modified it a bit, the brackets here, so it's lower than usual, and that makes it fit into the drawer. All right, so that's it for the single drawer. Now I'm going to finish up this video by, first of all, a huge thank you to my little brother. He helped with the filming of this project, the showcase and the color grading. I've learned a ton from him, so thank you very, very much. Also, Magnetron.dk, the owner of the business, Mads, he has guided me through this while I was in a very difficult mental state due to the global health crisis, and I'm very grateful for that. He put together a little team who helped me out with a lot of the details, especially in the drawer. So that was just a critical part of this being successful and working. So he has a business where he builds high-end custom PCs. Go check him out. He also does regular PCs just for us ordinary people. Definitely go check out his website. It's in the description. And thank you very, very much. Now, I want to clear out a few misconceptions. First, for example, that this system is going to catch on fire. Like, it is not going to catch on fire, trust me. A 60mm AlphaCool X-Flow radiator with 3 120 black noise, high performance, low noise turbine fans is going to do the job just fine. The temperatures here are clean, they're good, they're what you would expect from a water-cooled high-end desktop PC. Like, what is going to affect this is how you apply the thermal paste. Not that there's a little bit of oak wood surrounding it. So, also I will be putting up a few charts on the screen now so you can verify that for yourself.
Alright, so here we see the Witcher 3 with the 65 degrees Celsius on the CPU and 58 on the GPU. So that's maxed out. Also, I've included a few benchmarks here. You can compare that to what you find on the internet, but overall it's above average.
So the temperatures here are actually a lot better than I ever thought. The system, like just the way the radiator works and the flow and all of that, it's actually really good. It's much better than I originally thought, and that's very important because if you order this, it's standard for the radiator to be pre-installed, or along with the reservoir and so on. So it really needs to work. It's quite important. So yeah, that's it. Thank you so much for watching. I really hope you got some value out of this. I hope you enjoyed my content. If you don't dislike the video, leave a comment explaining why. It's fine with me, I don't care. I just want to make the single best storytelling, computer building, awesome content on YouTube. Thank you for watching. Bye.